not, maybe it's not a question because you show us the simulation result, but this one, fifth, could be very instructive. No, fifth, not fourth. Here, if you switch off in the time t, more or less, 600 amps, should be any spike because on the inductance is the load. So pay attention what happened in your switch of 600 amps. Second one, please pay attention what happened in the line according to the harmonics, according to the quality of the energy in the mains. As I see from the first picture, it's an electronic industry. They are very sensitive for any injection of the harmonics into the mains. So please be so accurate in investigation later. 600 amps immediately, and what happened in the mains. Lovely.
Thank you for your recommendation.
One more question. What kind of transistors did you use in the linear mode?
In the prototype, we used the IRF-20.
No, I mean, what type of transistors? Not the company or not model, but the IGBT, MOSFETs. Ah, MOSFETs.
We use that IRF, so there is a MOSFET as well. It's a very nice idea.
Thank you.
One question? So I have the last one in the session. I want to ask you, why don't you use the switching converter operating all the time? Because if you have the converter, the converter operating all the time, the losses will be lower, smaller. And only the idea of the linear converter could be to help the switching converter to achieve the desired quality.
We need to have very high the current regulation accuracy, so the switch converters can't provide that.
But if I'm right, if you put the slide numbers, I think it's 5, I think. Not 4. For example, let's say in the period between after the switching converter 1 is operating, no? The linear converter 2 is operating also. There are times where the switching converter 1 is operating and also the linear converter 2. There is?
That stage is not.
No, before. Because you say that the linear converter compensates the voltage, the current drop of the switching converter.
Yes.
So I suppose both are operating at the same time.
Yes.
So I propose the idea of that you apply in this time will be applied in the whole operation of the converter. Could you study if the losses could be reduced?
Efficiency.
Okay. No more questions, I suppose? No?